Hey everyone, welcome back to another episode of the LlamaIndex Webinar series. Today is shaping up to be one of our most popular webinars/workshops ever with property graph indexes in LlamaIndex in partnership with Neo4j. And so this is going to be a special workshop on teaching you how to build advanced knowledge graph RAG, and you'll be able to learn how to use our brand new property graph abstractions, both to construct an existing graph as well as to query a graph. And so we're excited to host Tomaz from Neo4j, as well as Logan from our side. And without further ado, feel free to kick it off.
Okay, so like I said, yeah, I'm happy to be here and talk about graphs. So as mentioned today, we're going to talk about the new property graph index integration in LlamaIndex. And if you might be wondering, property graph, what actually is that, right? Because most of the time, I don't know if I can remove this. So most of the time, when dealing with graphs, especially in the RAG like frameworks, what we see is usually triples, just like subject, relationship type, and then object, and the other way around. But actually, property graphs have now got an actual standard. And there's the new GQL standard, which is part of the ISO committee. And that's very exciting. But basically, property graph, as you might imagine, means that nodes have properties and relationships have properties as well. So, for example, here we have one node, and it has properties name, Amy Peters, date of birth, employee ID, right? But it also has this one special property that we call label in property graph models. And as you can see, for example, the green node has an employee node label, right? And node labels are used to put nodes into sets of categories. So for example, in this example, we have three node labels. So we have employee, company, and city. And as mentioned before, relationships can also have properties, right? So it's a slightly different data representation than what you might be used to, like from the previous, let's say, implementation in LlamaIndex, the knowledge graph implementation, where we only dealt with triples. So that's about property graphs. And now let's talk a little bit about property graph index integration. So the flow that most of the time you will follow when you're using property graph index integration, you start with a bunch of documents, and LlamaIndex has great support for various types of documents, so I will not go into that. But basically, documents, you can think of them as just wrappers around text. And so basically, we take a bunch of documents and we pass the text from those documents to graph constructors. So in the integration that Logan did, you can use one or multiple graph constructors to create a knowledge graph. And we'll talk a little bit more about them later. I'll show you which are available out of the box. And so the graph constructors extract like structured information from documents and store them as a graph in the knowledge graph. So there are a couple of integrations that LlamaIndex already has. As I'm from Neo4j, we'll focus on the Neo4j integration, but there are others as well, and probably more coming up. So once you've built your knowledge graph, on the other side, we have the so-called graph retrievers. So the graph retrievers, their job is to basically, based on the user question, they have some sort of logic they can use to retrieve data from the knowledge graph, right? And again, there are a couple of out-of-the-box retrievers that you can use, and we'll also show how easy it is to define a custom graph retriever in the workshop later. So that's basically the kind of the flow that you can think of, and what LlamaIndex does is it provides graph constructors and graph retrievers. I mean, obviously also the other parts, just that the graph constructors and graph retrievers are part of the new property graph index integration. And the idea is that they are very modular and customizable, so that if you're a beginner, you can just use something out of the box. But if you're like advanced user and you need something custom, it's very easy to customize the pipeline for your needs. So let's at high level property graph construction, as I said, we take a bunch of documents and we construct a knowledge graph. So here I have an example documents where like former OpenAI employees founded new companies, right? So for example, here you would have 4 different documents mentioned with some information, right? But the nice thing about knowledge graphs is that you kind of condense that information and unify it, right? So that basically the information that was previously spread across multiple documents is now easily accessible and nicely represented in a knowledge graph. Okay, and then I prepared a couple of slides, what is available out of the box in LlamaIndex. So out of the box, we have 3 graph constructors. The first one is the so-called implicit path extractor. And what it does, it just, we have a new word for it. It's called a lexical graph. But what it actually does, you just take the green node is the original document. And what it does, it just chunks the document. So what's this, like grayish nodes are text chunks, right? And text chunks are connected to the source document. And then also we have an ordered list of text chunks so that we know how do they follow each other. So this is the implicit path extractor graph constructor, and it doesn't require an LLM because it's just basically chunking up and then creating a linked list of text chunks. So, and then the next one is the simple LLM path extractor, and as the name would suggest, you need an LLM for that. And from what I've been digging around in the implementation, how the simple LLM path extractor works is basically through prompt engineering. So you, in the prompt, you define what like how the output should look like, and then you provide a parsing function that extracts that output from an LLM and creates a knowledge graph. So it's, I would call it like a prompt-based solution, and by default, all nodes have the same label, or like the default implementation, all nodes have the same label. And again, the purple one is the text chunk. So we always store the reference text in the graph as well, and then the entities that were mentioned in the text chunk. We have the mentions relationships to those entities. And then obviously entities can have relationships between each other, right? So for example, Amelia Earhart was American aviation pioneer. Right, and this is kind of the simpler version of graph extraction. Now, obviously, you can customize it and make it more advanced, but by default, all nodes have the same label. Yeah. And then the more advanced is the Schema LLM path extractor. So here you have the ability to define which nodes and node labels and relationship types you can extract. This one will also show use in the workshop, so you'll get to see in practice how do we define the schema. But basically, as you can see, by different colors of nodes means that they have different node labels. And again, the purple ones are the text chunks, the reference text chunks, and then the text chunks mention the entities that appeared in those text chunks. And then obviously we have a bunch of relationships between those entities as well, right? And this one works best with LLMs that provide function calling, like native function calling, like the commercial LLMs like OpenAI, Gemini, Mistral, probably some others. Grok is a nice one as well. Grok is actually a really nice one because it's really fast, and that's really nice for the knowledge graph construction. But yeah, so it works best with LLMs with native function calling, but Logan told me that it will also work with models that don't provide native function calling, just not as well, or maybe the schema should be simpler in those using those LLMs. But as I said, I haven't tested it out, but maybe you can test it out and let me know, or let us know how it works. So this is basically the out-of-the-box graph constructors that you can use. And then what's not in the LlamaIndex yet, but since LlamaIndex provides low-level connections to graph stores, Neo4j in this example, if we can also come up with custom entity disambiguation, which we will do in this workshop as well. And entity disambiguation just means that if you have multiple nodes in the knowledge graph, excuse me, that reference the same real-world entity, you kind of want to merge them together into a single node so that you have a better structural integrity, right? So for here in this example, this node ends with a limited, this one has abbreviation limited, and this one doesn't have limited, right? But it all references the same node. So that means that's why we want to merge it into a single node so that we have better structural integrity. And in the workshop, we'll use a combination of text embeddings and word distance heuristics to find potential candidates and then merge them together. Here is basically, if you're anxious, you can follow this link, and this is basically the notebook that we'll be using today. Okay, and then on the other side, we have property graph retrievers. So as you see, I just took the previous image and just slice it up because here we have the remaining of the arrow. But the graph retrievers, as I said, based on the user input, they have some logic how to retrieve information from the knowledge graph, and then pass that information to an LLM so that the LLM can generate the final answer. So basically a typical RAG pipeline. And we have, I think, 4 out-of-the-box retrievers that you can use. So here I didn't have time to draw nice diagrams, so I just summarize them quite quickly. So the first one is the LLM synonym retriever. It takes the user query, generates synonyms using an LLM, and then it finds relevant nodes using exact keyword match. So that's really important because LLM is not aware of any values in the database when it's generating the synonyms. So it's not a given that the LLM will know how to construct the keywords so that they will match any nodes in the graph, right? So because it uses, at least the Neo4j integration uses exact keyword match, it's the least reliable, right? Because it needs exact keyword match. We could basically optimize this to allow some misspelling or stuff like that, but at the moment it's using exact keyword match. And then once it finds relevant nodes, it returns basically the direct neighborhood, or basically you have an option to decide how many, or like what's the distance, what's the neighborhood size of the nodes that you want to return. So by default, we return just direct neighbors of that node. And then the second one is the vector context retriever. So in the previous one, we used exact keyword search to find relevant nodes, but here in this example, we're using vector search. So that means it's more robust and less reliable on exact keyword match, right? Because with with vector search, you will always get some results from the database because you take top n. And then hopefully some relevant nodes are identified using vector search. And then we just do the same thing as we did in the previous one. We just return the direct neighborhood of relevant nodes that were found using the vector search. And then another one is the text-to-cypher. So as the name implies, we take the text and use an LLM to generate cipher statements. So this is kind of very flexible approach, right? Because the LLM can construct any sorts of cipher statements. So for example, with vector context retriever, right? When you're just finding for searching for relevant nodes using vector search and then returning direct neighborhoods, it's very hard to answer questions like how many nodes are in the graph, because it's like an aggregation query, and vector context retriever is not suitable for aggregation queries, at least not like on the global scale. But like, for example, with text-to-cypher, you could ask it questions like how many nodes are in the graph, or like how many people are in the graph, and the LLM will generate appropriate cipher statements and return that information for you, right? So text-to-cypher is much more flexible than the previous tools, but there's obviously always a trade-off that it's less reliable because we're using LLM to generate cipher statements, and that's at the moment how I see it, it's mostly correct, but but not like always. So you're kind of trading off flexibility for a bit of accuracy. But then on the other side, what you have is also some different, like Text-to-cypher allows you to also do aggregations and stuff like that, which the previous retrievers didn't allow you. And then the last one is the so-called cipher template retriever. And here, instead of generating cipher statements with an LLM, you basically define the cipher statements you want to be executed, and you just parameterize, or like provide like a parameterized cipher template. So basically, you have a cipher statement with like one or more parameters, and then at query time, basically the LLM, you provide instruction to an LLM how to populate those parameters, and then at query time, LLM extracts relevant parameters it needs to use with the cipher template, populates the template, and then executes the predefined cipher template. So that's where the template comes from, because it's predefined. And then here I have questions, but let's do a demo.
Tomaz, I'm just going to read through some questions in the chat so far, just to make sure we cover some of them before the workshop. The first is, I think one question is actually about using LLMs, and if you have a set of recommended LLMs that you think are better for, say, like knowledge graph construction, as well as the cost of running LLMs across a large corpus of documents to construct a knowledge graph. I'm curious to get your initial takes there, as well as like recommendations for some of these users. Some of them are thinking about using like Grok, for instance.
Yeah, so what you will see is that graph construction, like LLMs and graph construction, is very model dependent. So different models will generate different graphs, and it's very like even different versions of GPT-4 will behave differently. So I did some testing, like I'm not like an expert in all of the LLMs, but for example, what I will tell you, when you're using like a predefined schema, like the GPT 3.5 will try to fit all that information into the schema so that it kind of overfits information into the schema where it's not really, where it wouldn't really fit in reality. But then GPT-4 Turbo and the 4o are much better at like ignoring the information that is not part of the schema. For example, if you want to use, I would really recommend using LLMs that are fast. So for example, GPT-4, just throw it out of the window because it takes forever and it's costly. Right? So in that, like Grok is really nice because it's really fast. But then the problem with Grok is they don't want to take our money just yet. So hopefully when they will be taking our credit cards, that's something I would definitely look into. But like in general, it's like the better the model, the better will be the results, the more it will follow the prompt instructions, right? So
Great.
yeah.
And just following up with just one more quick question is, you know, this might not actually quite exist in some of our abstractions right now, but one of the questions is around like dealing with missing information from the graph, which sort of implies this, like maybe you do some LLM construction pass. It's not completely exactly where you want it to be. And so you do some human in the loop pass to try to like modify and shape the graph to, you know, better reflect what you want out of that data. Have you seen that like kind of human in the loop approach towards like graph construction?
So it's not really human in the loop. It's more like they have some heuristics, because I didn't really mention, but if you want to take a look, the graph rack by Microsoft paper is really nice. and it deals with some of these questions. So the first one is also like what types of what's the size of text chunks you should use, right? And the thing is, it's kind of funny, like the number of nodes and relationships is kind of irrelevant to the chunk sizes. So that just means if you're using smaller text chunks, more information will be extracted. And if you're using bigger text chunks, like the overall number of extractions will be the extracted information will be the same. But since you're using larger text chunks, right, on the like in summary, less information will be extracted from larger text chunks. So that's one thing they mentioned in the paper. And then the second thing they mentioned, they have some sort of heuristics where they can decide, okay, not enough information was extracted from the text, and then they do a second run. So basically, instead of having a human in the loop, it's kind of automated and saying, okay, you didn't do a good enough job. Now let's do a second pass on the graph extraction.
Oh, okay. Yeah, super interesting.
Any other questions? Should we go?
Feel free to carry on. There's a ton of questions, but I think we'll do a workshop.
I mean,
we
can, because the extraction part will take a couple of minutes, and we can answer questions. So here okay. I define my graph store. So okay, just a second. Okay, that's fine. And one thing I also noticed is that people are sometimes confused by documents because like all LlamaIndex mostly deals with the document, right? But document is just a wrapper around the text. So it's very easy to go from text to document. We just instantiate the document with a text property, and that's about it, right? So here in this example, we're gonna create a bunch of documents based on the news. So we have a bunch of news, and we're going to use GPT-4o. And for example, one thing that's also interesting, there's like a lot of things that comes popping up. And one thing I noticed today was, today or yesterday, somebody did some benchmarks, and they said basically that if you're using slightly higher temperature than 0, even for the deterministic tasks, you get better results. And that's like, and it was specifically for GPT-4o, right? So again, that's kind of very interesting, and we're all learning as we go along, right? But as mentioned, we're gonna use the Schema LLM pet extractor in this workshop. So with Schema LLM pet extractor, you have to define the types of nodes that you want to extract. So here I went for person, location, organization, product, and event. So it's mostly a very typical extraction. And then there's the event, which is kind of more ambiguous, and it allows the LLM to extract any type, like a lot of information, right? Because event can be anything, basically. And then we also have to define the types of relationships we want to extract. So here I focused more on the like organization business part, where we have suppliers, competitors, acquisitions, subsidiaries, CEOs, stuff like that. So we're gonna hopefully extract some business relevant / financial information, hopefully, from the knowledge graph. And then, so this is the first part of the, when we are defining the schema. And then the second part is we also have to define which relationships is assigned to each person, right? Because not all relationships can be part of all node labels, right? So we have to define, so for example, a product only has provides relationship, and then provides is only on the organization. So then ideally the LLM would generate only provides relationships between organizations and products, right? Because it doesn't really make sense to have provides relationship from location to, let's say, a product. So this is a little bit more granular schema definition that we need to provide. And then we just, let's go with 100. And then we just pass the possible entities, relationships, and validation schema to the LLM. And here you have the strict mode. So strict mode, like even if you provide instructions to the LLM, which types of nodes and relationships it should use, it doesn't really mean that it will follow them. Oops, where are you? 100% correct, right? Because LLMs are just LLMs, they do what they want. And then Logan implemented a strict mode. So it means that, but since we know the types of relationships and nodes we expect, we can filter them out if we want to in the code, right? Or we can leave any other nodes and the relationship the LLM identified. So in this case, let's just allow any information the LLM decides additionally to extract. Now, GPT-4 is quite good at following the provided schema, right? But other models, and this is also because, as I said, GPT-4 is a native function calling model. So when you're using functions or tools to extract information, structured information, it will have much better accuracy. Whereas like Llama 3, which is not Grok, so Llama 3 via Ollama, right, doesn't have function calling. It's still a really good model, but it might not follow the schema always, right? So that's why you have the option to filter it in post-processing if you want to or not. And here we'll go for the not. And we're gonna extract information from 100 articles, and it's gonna take like 2-3 minutes, I think. So we have time for a couple of questions.
Yeah, for sure. I'm trying to figure out what questions asked. Maybe one thing is actually going back to the retrieval side. So there is vector search with the vector context retriever, and then there's also text-to-cypher. You mentioned some limitations of text-to-cypher. Like in your mind, like what are some of the maybe like tips and tricks you see in getting text-to-cypher working a little bit better for users? In terms of making sure it generates more reliable cipher queries, how to make sure it actually retrieves relevant context.
So I mean, this is kind of a hard question. So text-to-cypher works good for like when the user knows what's in the database, right, and knows how to ask the questions that fits the schema. Right, so that's one thing. And then how do you achieve that? So what you could do is you could have some query rewriting steps that take the user input and rewrites it into more of a question that fits the graph schema, and it's a little bit more verbose or implicit on how it wants the information to be retrieved. So that's one thing. Obviously, providing it with few short examples is very helpful because by default it uses zero-shot generation, right? We just give it the graph schema and then hope for the best. But what you can also do is you can also provide it few short examples and then hope that it follows those examples. And obviously the thing is like with more complex graph schemas, there's like just how to describe those schemas takes a lot of tokens. So when and then maybe not linearly, but the bigger the size of the schema, the less it will, I mean, yeah, the worse the accuracy will be. So what you can also do is then just provide parts of the schema. So instead of having one text-to-cipher that deals with the whole graph schema, what you can do is you can have like an agent with like several tools, and then each of those tools focus on different parts of the schema, right? So you kind of lower the complexity of the task. Yeah.
Cool. No, yeah, that makes a lot of sense. I know it's about to finish up, but that maybe just another question, and we can also carry this over after things are done. But is Neo4j designed to work with like technical document use cases like patents and scientific papers? Like, will it help in identifying and building relationships between science technical concepts? This is one of the questions from the audience.
Yeah, so yeah, how you say, Neo4j is domain agnostic, so you can store any information you want in it. That being said, it's quite funny that you mentioned patents and technical documentation, because that's really relevant, or at least what we see in a lot of pharmaceutical or biomedical companies, right? There's a lot of money in patents. And for me, it was also interesting. For example, biomedical companies, when they have this great idea, what we should do or what we should research, you know what they first do? They check if there's already a patent, right? And then if it's already a patent, they don't research it because it won't make money. You can't patent it. So, and I've seen basically like big pharmaceutical companies, they all have their patent graph. They all like scrape like PubMed. You don't actually have to scrape it because it has APIs, right? But it's like, you can think of it like biomedical technical documentation, like with all the latest research, and they generate knowledge graphs from those, and then use it to inform or recommend. So one thing they do is basically they generate graphs from all the latest research, and then they use recommendations to recommend to doctors based on their specialization which articles they should read, right? So yes, definitely Neo4j can be used for patents, and is actually used by existing customers for patents and technical documentation.
Super interesting.
Yeah. Okay, yeah, so now that we've imported the graph, we can also take a look at it. Why not? Right, graph visualizations are usually quite nice. So let's see, we have, okay, so we can see that, for example, let's see why we have an award. We have 2 awards, no labels, so that's kind of funny, but it wasn't in our description, right? So even GPT-4o can decide, ooh, awards are really nice of the FA Cup and the English legal title. So let's see, basically probably will be who won. So it was Gordon McQueen was awarded the FA Cup, so probably there should be a football team in there. But it's interesting, you can see that even, and we have a disease as well, one disease. So even GPT-4o can decide to add some information that wasn't in the schema. So that's why we have the strict mode, right? if we use strict mode true, we wouldn't see these nodes in the graph, because obviously we would filter them out programmatically, right? And then let's try to see if we have. I'm trying to find if there's anything more connected, but basically, unfortunately, okay, cool. So, and let's so we have, if, for example, United Health Group is a node, and now we can see a bunch of competitors, right? And we can also see probably it's not doing so well because it had a stock sell-off and stock price decline, right? And this is, as I mentioned, event is kind of ambiguous and it can be a lot of things. So in this case, it was stock has invested stock price declined, and John Rex works at United Health Group, right? So like overall, the GPT-4o followed the schema, right, quite nicely, and we can see like a nice graph over here. And let's go forward. And then, as I mentioned before, entity deduplication is kind of a must. I think it's often overlooked, but you kind of want to find entities like nodes in the graph that reference the same real world entity and merge them. And here we have a kind of involved cipher query, which took like 8 hours to come up with by multiple people. But in the end, we found like a nice way of using text embedding. So here we have the cosine similarity threshold and then word edit distance. So how many characters can you change in the string to have it the same? And you can see it works quite well. Like, so for example, Bank of America and Bank of America Corporation, Warner Music Group, like Newcastle United, Coinbase. So overall, it works really nicely to find like these duplicates, but obviously it's not perfect because nothing in life is perfect. So for example, this one is kinda, I mean, it's the same, it's still Jeffrey's Virtual Space Summit, right? But one is Fireside Chat, which is, yeah, maybe not really, but fine. And for example, Baltimore, this one also, right? Okay, I can understand that these two should be merged, but maybe this is a city and shouldn't be merged together, right? So as always, you have the option to tweak these two parameters, and you also have the option to then do some manually, like human in the loop. Here, human in the loop is kind of important to know what entities are you merging. But I think like just having like some sort of baseline to start with is really nice. And I think this cipher query turned out really nice because you can see a lot of entities that should be merged together. And let's just merge them together. And then for the last part, as we said, we're gonna implement a custom retriever, and we have the 4 existing ones. But here we're gonna implement a retriever that first identifies all the relevant entities in the text, because, for example, the vector context retriever just takes the whole string, embeds it, and then finds the relevant nodes, right? But what if multiple entities are mentioned in the text? Then like vector index might not be the greatest, because if it will embed the both entities into a single embedding, and then I don't really know who really knows what happens with those numbers. There's a bunch of zeros and ones, and what do they actually represent? Who knows? So what we'll do
Tomaz,
is
really quick before the retrieval piece. Actually, quick question on the entity disambiguation. That cipher query, I mean, given how involved it is, but given the fact that I imagine like a lot of people probably need to do some sort of dedupe, is this like a template that's just like shared publicly? Because it seems like it would be generally useful for a lot of people.
yeah, this is part of the blog. This is all available over here. I mean, we can add a link in the webinar if we know how to, but it's this one. So if I know how to do chat, let me spam it a little bit. To everyone in the
No problem. I think we shared the notebook. Yeah, we shared the notebook in the chat, but basically like that, basically to the audience, it's like, if you want just a nice cipher query to do entity dedupe, obviously there's some limitations. You probably need to tweak the word similarity and those types of things a little bit, but like if you want an existing template to go off of, you can just like copy and paste from this notebook, right? Because it's a pretty long cipher string. So I would imagine a lot of people are going to be able to write this themselves.
I mean, it's also, I would make it a model in LlamaIndex. It's just that then it's like very Neo4j specific, and then like it doesn't fit the best into LlamaIndex, right? Because you guys want to have things that I say integration agnostic. So, but maybe we can figure out that in the coming months how to add that, because it would be nice to have those like out of the box, right? You just expose these two parameters and let it do the magic, right? But maybe this is something for
Yeah, no worries. I think even the raw cipher is useful for the audience. And then just doing a quick check on time. I know we have technically 5 to 10 minutes left. But I know the last section is just like the custom retrieval section. But maybe we can just like walk through the high level concepts. Maybe just like go through the overall class, and then that should be a good conclusion to this workshop.
Yeah, we can do this actually quite fast. So as I said, we extract entities from the user input, and we use a Pydantic, OpenAI Pydantic program. So basically, again, I would imagine we kind of use function calling behind the scenes, right? We say, this is your input parameter, and it's a list of named entities in the text. And we ask GPT-4o to extract it. So basically, then, okay, I'm rambling a bit, but so how do you define your custom retriever? So your custom retriever just needs 2 methods, or actually just one, but the init is also quite nice if you want to instantiate, for example, some other functions or classes. And in the init here, we instantiate the entity extraction, which is the OpenAI Pydantic program, right? To extract relevant entities from text. And then we also define or instantiate existing vector context retriever. So we can use it. And then in the custom retriever, it's actually the code is very simple, right? We just extract or find, detect is maybe the best word, if there are entities in the text. So if there are entities in the text, we just run a vector retrieval for every entity in the text. And if the LLM doesn't find any specific entities, we just use the vector retrieval on the whole text, right? And that's basically it. And then you have a couple of options. How you on the structure or format of the results that you can pass back to the LLM. And here in this example, we just pass back the text. We can remove this because we don't need to change anything. Yeah, and then we just basically instantiate the whole thing, and let's see what happens. So if you ask what do you know about Maliek or Dada, basically the LLM detects two entities, right? And then for each of those two entities, it runs vector retrieval separately, so that it kind of ensures that we will get information for both entities, right? Because if you just use vector retrieval on the whole string, or text embedding on the whole string, you might just get it for one entity, but not the other, right? Because if you use topk for, maybe one is more significant in the text embeddings. But with this approach, we make sure to cover all the entities, so we get nice answers for both entities. So yeah, that's like a high-level overview of the retriever, and now we can answer a couple of questions again.
Yeah, and maybe just to kind of like say a few words to help wrap this up. I think what Tomaz really showed you was an end-to-end process of both like constructing a knowledge graph and then also retrieving from it. And not just that, like showing both the high-level API as well as the lower-level API. So whether you're a beginner user for knowledge graphs and LLMs and LlamaIndex and Neo4j, you can basically do all this stuff in about like 5 lines of code. Or if you really want to go in, you're an advanced user, you're pretty familiar with knowledge graphs. We offer a lot of opportunities for you to define your own custom extractors, right? With our core abstractions, like a robust like property graph store, like the underlying low-level like storage system to I think a lot of people are interested in knowledge graphs. We basically see it as like a superset, a potential superset of existing RAG solutions, especially if you're able to leverage these like properties and relations to help augment your retrieval. And there's a lot of very interesting like an enterprise developer, you're building knowledge graphs within the company. Feel free to reach out to one of us for any sort of like blog posts, case study. We're always happy to feature like really interesting use cases of like knowledge graphs, LLMs, like LlamaIndex and Neo4j, right? And so always happy to showcase like very interesting applications. But hopefully this workshop was useful to all of you today. And we'll have this on our YouTube channel. And then basically, hopefully we'll do, maybe even like a series covering like other types of topics as we go forward. But we're definitely looking forward to new types of applications built with like knowledge graphs, KGs, and LLMs. So I think with that said, it's probably a good time to generally wrap up. And really sorry, I think a lot of you had a lot of questions in the chat. We weren't able to get through all of them, but we'll have this YouTube video out, and basically feel free to comment there as well. So thank you, everyone. Thank you, Tomaz, and thanks, Logan, for hopping in.